Momentum, made by Gun Agarwal. Agenda of my PPT is introduction, derivation of equation, Newton's second law of motion, momentum and inertia, and three types of inertia. Examples of three types of inertia: formula to calculate momentum, question based on the formula of momentum, formula to calculate force, and question based on the formula of force. Introduction. Momentum can be defined as mass in motion. All objects have mass, so if an object is moving, then it has momentum. It has its mass in motion. Momentum depends upon the variables mass and velocity. In terms of an equation, the momentum of an object is equal to the mass of the object times the velocity of the object. Derivation of equation. If a body is moving at initial velocity u and accelerates uniformly with an acceleration a for time t so that it changes final velocity to v, initial momentum is equal to p1 is equal to mu, final momentum is equal to p2 is equal to mv. Change in momentum p2 minus p1 is equal to mv minus mu, and m should be common and v minus u in the bracket. According to the second law of motion, force is equal to F proportional. So F is proportional to change in momentum upon time. F is proportional is equal to P2 minus P1 is equal to M V minus U upon T. Force is equal to constant into mass into acceleration, where K is constant of proportionality and A is equal to V minus U upon T. Newton's second law of motion. Newton's second law states that the rate of change of momentum mv minus mu upon t of an object is directly proportional to the unbalanced force in the direction of force. Force applied by Newton causes the rope to move only slightly. Why don't you try try to move the rock. Force applied by the horse causes the rock to move a greater distance. Newton applies less force, less acceleration is produced. Horse applies more force, more acceleration is produced. Hence, force is proportional to acceleration. Force is proportional to acceleration. Distance 1 meter. Mass of Newton is less. Applied force is less. Distance 1 meter. Mass of horse is more, therefore applied force is more. Therefore, force is proportional to mass. Hence, force is proportional to mass into acceleration. The end. Momentum and inertia. Inertia is another property of mass that resists changes in velocity. However, inertia depends only on mass. Inertia is a scalar quantity. Momentum is property of moving mass that resists change in a moving object's velocity. There are three types of inertia: inertia of motion, inertia of rest, and inertia of direction. Examples of three types of inertia are: first, inertia of motion. The passengers fall forward when a fast moving bus stops suddenly. A person falls forward while getting down from a moving bus. A luggage is usually tied with rope so that it doesn't get down. Second, inertia of rest. The carpet is beaten with a stick to remove the dust particles. When a tree is vigorously shaken, then some of the leaves fall from the tree. And the dust, inertia of direction. When a fast moving bus negotiates a curve on the road, then passengers fall away from the center of the curved road. Second one, the sparks produced during sharpening of a knife against a grinding wheel leave tangentially to its rim. A stone tied to a string is whirling in a horizontal circle. If the string breaks, then the stone flies away tangentially. Formula to calculate momentum.
Imagine you are on a treasure hunt, and after months and months of searching, you have found the lost temple and can finally loot all of the treasure. But as you try to do that, you realize that the chest is behind a huge glass wall. To make matters worse, your arch rival is also there to grab the gold, and he has a giant rock to help him. You only have a marble in your pocket. What should you do to break the glass wall and take all of the treasure? Let's see your rival's plan. If he rolls the rock, the glass will easily break. Can you roll your marble and expect the same thing to happen? That might not work for you. But why? An obvious difference between the marble and the rock is that they have different sizes. To be precise, they have different masses, and the heavier rock is the one that is able to break the glass because it applies a larger force on the wall. What you've just figured out is that the force applied by an object depends on its mass. So using the rock, the glass will break easily and your rival might win. But now the pressure is on you. How can you break the glass with a marble? While thinking, suddenly you have an idea. You check your other pocket and find a toy gun. Would shooting the marble break the glass? This plan might definitely work. But why? Because now the marble would have a much greater speed. A greater speed will result in a greater force on the glass wall, and it would break. From this plan, you've realized one more important factor that affects the force applied by an object. It's velocity. If you combine the two things you've just learned, you can say that the force applied by an object depends on its mass and its velocity. What you just figured out, Newton had discovered a long time ago. He felt that if we combine mass and velocity, we can talk about force and actually calculate it. This gave birth to the concept of momentum. Momentum gives us a better idea about force. Let's see how. For an object with a mass m and velocity v, momentum is given simply as their product. We denote it by the letter P. So P is equal to mv. So the rock had more momentum because it had a greater mass. The marble had more momentum because of its higher velocity. And because of this large momentum, both were able to break the glass. We can use momentum to understand a lot of other things. For instance, ever wondered why a fast bowler takes such a long run up when he bowls? Long run ups help him gain velocity. What he's basically trying to do is gain momentum. This momentum helps him bowl faster. This same technique is used in many other sports like the javelin throw. The athletes take a run up to gain momentum, and this helps them throw the javelin as far away as they can. Now that both you and your rival understand what momentum is and how it works, how about you both break the glass together and split the treasure equally? So everything's fair. I'm sure you're happy you learned these today. Force applied by an object depends on 1. The mass,
Mass,
and 2. The velocity.
velocity.
P is equal to mv. Momentum equals mass into velocity. But you're probably happier because now you're rich. And maybe you're right. In the next video, we'll take a deeper look at momentum, learn about its direction.
P is equal to m into v. V represent velocity, m represent mass, and p represent momentum. And SI unit is kg meter per second. Questions based on the formula of momentum. Question number 1. Calculate the momentum of a rock of 1 kg when it is fired from a gun with a velocity of 100 meter per second. Mass of rock is 1 kg and velocity of rock is 100 meter per second. So, as we know that mass into velocity is equal to momentum. So, momentum is equal to 1 into 100 and it is equal to 100 kg meter per second, which is equal to 100 Newton. Here comes the question 2. Calculate the momentum of a ball having mass of 1 kg and is thrown using hand with a velocity of 0.1 meter per second. Mass of ball is 1 kg and velocity of ball is 0.1 meter per second. So, momentum is equal to mass into velocity. Momentum is equal to 1 into 0.1, which is equal to 1.1 kg meter per second and equal to 1.1 Newton. Now comes the formula to calculate force. Force is equal to m into a. A represents acceleration and m represents mass. SI unit of force is Newton and Newton is symbolized by N. Questions based on the formula of force is question number 1. How much net force is required to accelerate a 1000 kg car at 4 meter per second square? Force is equal to mass into acceleration, and acceleration is given as 4 meter per second square and mass is given as 1000 kg. Therefore, as we know, F is equal to m into A, so 1000 into 4 is equal to 4000 Newton. Now, question number 2. Calculate the force needed to speed up a car with the rate of 5 meter per second square if the mass of the car is 1000 kg. According to the question, acceleration is 5 meter per second square and mass is 1000 kg. And we have to find out the force. We know that F is equal to mass into acceleration. So 1000 into 5 is equal to 5000 Newton. Therefore, required force is equal to 5000 Newton. That's the end.